Today we're going to be talking about dot product. We're going to be talking about what it is, what it looks like. We're going to be talking about how to perform operations with the dot product, and we're going to be talking about how to apply it to vectors. Reminder that your test is on Tuesday. It'll cover all the content that you see on your table of contents right now. On Monday when you come back, we'll work on a review so we can clear up any confusion that you might have. Let's go ahead and take a look at dot product. If you're asked to find dot product, it'll look like this notation right here. It'll have the two vectors that you're finding the dot product between, and it'll actually have a dot in between them. To find the dot product, you're going to be given the component form of two vectors. So for vector u, we're given this is the component form. For vector v, we're given this is the component form. If we want to find the dot product between the two, what you're going to do is you're going to take the first value and the first vector, and the first value and the second vector, and you're going to multiply those together, a times c. You're then going to add on the second piece, b times d. So you're going to multiply the two second pieces together, so b times d. This formula is given on your reference sheet, but again, it's just two simple multiplication problems, and you add them together. Little jingle to help you remember is it's first times first plus second times second. First times first plus second times second. Now, when you do this, you're going to get just a plain number. It's just a constant, like 7 or -9. It is not a vector. The result of a dot product is not a vector. It's just a plain number. In this first section down here, we're going to work on some operations with dot product. If you're asked to do anything with dot product, the first thing you find is the dot product, which is a constant or just a plain number. Then you're going to distribute the dot product to whatever vector you're asked to multiply it with. The answer is a vector because we're multiplying whatever that dot product is to a vector. We're going to use those same distribution skills that we used in yesterday's class where we are dealing with operations. So let's look at number 1. We're given vector A, B, and C in bold up at the top of the examples, and we're asked to find, in number 1, the dot product between A and B multiplied by vector C. When we're doing this, we're going to start right here with the dot product. So we're first going to find the dot product between A and B. In order to do that, we're going to look at vector A, find the first number up there, 4, and we're going to multiply it with the first number in vector B, -6. So we have 4 times -6. We're going to add it with the second number multiplied together, so -5 times -1. We're going to simplify that down. So we have 4 times -6 is -24, plus -5 times -1 is 5. -24 plus 5 is -19. Notice how when we found the dot product, we just found a single, like the result is a single number. It's just a constant. But now you'll notice that we're asked to take whatever that dot product was and multiply it by vector C. So we're going to take -19 and we're going to multiply it by vector C, which we can see up top is 2, 5. To do that, we simply distribute -19 times 2 and -19 times 5 to get our final vector. -19 times 2 is -38. -19 times 5 is -95. That would be our final answer. Let's try out the same thing with example number 2. In example number 2, we're asked to find the dot product between B and C. You start there. To find the dot product between those two vectors, you're going to look at B, find the first piece, look at C, find the first piece, and multiply those together. So we have -6 times 2. We're then going to add it with the second vertical components multiplied together. So -1 times 5. Boil it down to get your 1 number. So we have -6 times 2 is -12. Plus -1 times 5 is -5. -12 plus -5 is equal to -17. So when we found the dot product, B and C, B dot C, we just found a single number, -17. To finish up this problem, we're asked to take that dot product and multiply it by vector A. If we want to do that, we're going to take negative 17 and distribute it to vector A, which from the top we can see is 4, negative 5. Take that negative 17, distribute it to both numbers. Negative 17 times 4 is negative 68. Negative 17 times negative 5 is 85. That would be our final answer there. That's how you deal with operations with dot product and how to find the dot product in general. Remember that the dot product is a single number. Let's flip it to the back. On the back, we're going to be talking about how to determine if two vectors are orthogonal, which is just a fancy word that means the same thing as perpendicular. Perpendicular means two lines intersecting at a 90-degree angle. So we're trying to determine if these two vectors are intersecting at a 90-degree angle. To do that, you have to find the dot product. If the dot product between the two vectors is 0, then the vectors are orthogonal. If, on the other hand, it is not equal to 0, then they are not orthogonal. So if they intersect, if the dot product is 0, that means they intersect at a 90-degree angle. In the next three examples, we're going to find the dot product, u dot v, and then we're going to determine using that if the two vectors are orthogonal or not. So let's take a moment and find u dot v here. To do that, it's first times first plus second times second. So we have 3 times 1 plus 4 times 1. 3 times 1 is 3, 4 times 1 is 4. Resultant dot product is 7. 7 is obviously not equal to 0, so these are not orthogonal. I want you to also be able to visualize this. So imagine you have vector u here. Its component form is 3, 4. That means in general, like from beginning to end, it's going right 3 and up 4. So it looks something like that. Vector v is going right 1, up 1. So it looks something like that. Those obviously are not intersecting in a 90-degree angle. So if you want to make sure that your answer makes sense, that should visually cue you in that they are not orthogonal. Let's do the same thing with number 2. We're going to find the dot product between u and v. So we take first times first, second times second. So we have 2 times 3 plus negative 1 times 6. 2 times 3 gives us 6 plus negative 1 times 6 gives us negative 6. You add those together, you get 0. When the dot product is equal to 0, that means they are orthogonal. Let's visually see if this makes sense to us. Vector u has a component form of 2, negative 1, so it's going right 2, down 1, so something like that. Vector v is going right 3, up 6, so something like that. You can see that visually it even looks like they are orthogonal to each other because they're intersecting at or combining at a 90-degree angle, intersecting at a 90-degree angle. Take a moment and try out number 3. In this case, we should multiply 3 times 6, first times first, plus the second times the second. 3 times 6 is 18. Negative 1 times negative 2 is 2. 18 plus 2 gives us 20. So these would not be orthogonal because the dot product does not equal 0. Visually, if you want to see this, vector u is going right 3, down 1. Vector v is going right 6, down 2. They're not intersecting at a 90-degree angle. The final way that I would ask this kind of question is like example 4. Find A so that the vectors v, which has a component form of 5, 3, and w, which has a component form of a, negative 2, are orthogonal. You'll notice that our unknown here is a, and we're trying to find out what a needs to be so that these two vectors are orthogonal. If we want the vectors to be orthogonal, we need our dot product to equal 0. So we want v dot w to equal 0. Remember, when you're finding the dot product, you take the first number and multiply it by the other first number. So in this case, we would have 5 times a. We would add it with the second times the second. So 3 times negative 2. In order for those to be orthogonal, we know that sum of those two should equal 0. Now we've got ourselves a nice equation where we can find out what a needs to be so that that dot product equals 0. We'd have 5a, 3 times -2 is -6, equals 0, and simply solve to find a. Add 6, divide by 5, to get a is 6/5. You can check yourself, of course, by taking that a and plugging it back in, multiplying the first times the first and the last times the last, and making sure that your dot product is 0. So make sure that today you're comfortable determining whether two vectors are orthogonal or not by finding if the dot product is 0, and make sure you're comfortable dealing with some operations with dot product. You can start your homework now.